This is the concept involved in this materials, and the concept is the topic is superalloys, and course name is advanced materials. Superalloys is one of the part of metals and alloys, advanced materials, and presented by Dr. Bhajan Sheth, Professor of Ramchandra College of Engineering, developed by Jaina Theory Technology University, Kakinada. When we are discussing about this concept, we have to understand the objectives involved in this superalloys is helpful for the gaining knowledge and utility in different environments. How this superalloys will be called and what is the need of doing superalloys is very important. These superalloys having the strengthening of different solid solutions like mixing of the elements, it can increase the strength, impurity of atoms, redistribute the lattice strength, and different concepts. Generally, the pure metals are the almost always softer than their alloys. And also, when we are discussing about this superalloys having microstructure, crystallography, phase diagram, mechanical properties, diffraction, and alloy design, drafting, heat treatment, applications, and how the superalloys have the different coatings, fabrication, and drying. These are the main structure and main image of the superalloys and how it will be manufactured and how it will be interlinked. And also, when we are discussing about this concept of the superalloys, we have to understand the how it will be called and what are the different logics involved in the superalloys. Generally, when we are going the concept and understanding of the superalloys, we have to know what is the superalloy. It is an important group of high temperature materials within the hot section of jet and rocket. Jet and rocket engines is applicable where we are using superalloy. And here the maximum temperature is 1400 degrees centigrade, minimum is 400 degrees. And also these superalloys having based on nickel, cobalt, and iron with large additions of the underlying elements, how it will be to provide the strength and the toughness and durability of the metal. And these concepts will be useful when we having the different categories and classifications like nickel versus cobalt based, and also these nickel versus cobalt based they are useful for the strengthening mechanism single crystals. These superalloys are to able to maintain high strength at high temperatures and having good corrosion and oxidation resistance at high temperatures like chromium aluminum. And the superalloys having good resistance to creep and rupture at high temperature. And the superalloys having the three main classes of superalloys is nickel base and nickel iron base, cheaper than nickel base and cobalt base. And how it will be helpful and what is the need of doing this superalloys. And this nickel base or nickel iron base or cobalt base, these are the conditions satisfying when we are hitting the more maximum temperature. You can observe this image, you can understand the concept and how it will be used in the superalloys when we are hitting and when we are manufacturing the food products. You can observe the figure having x-axis different elements and y-axis is melting temperature and how the elements involved and how the temperatures varies. This shows the clear applicability of the superalloys. You can observe what are the elements x-axis having tin, lead, silver, aluminum, magnet, copper, nickel, cobalt, iron, iridium, titanium, chromium, cobalt, molybdenum, tantalum, and and how these conditions find these elements and how the temperature. Minimum melting temperature for the elements will be between 400 and maximum 70 degrees Celsius. You can observe how the melting points will be vary. Melting points will be vary maximum high temperature, expected high. And you can observe the dotted lines having the expected high temperature spin. And you can observe the red spot shows the nickel, cobalt, iron based metals and the superalloys. This gives the element with respect to the maximum melting temperature and how it will be varying, and how it will be increasing to minimum level to maximum level, and how the different conditions satisfying at different points, corner points, and what are the elements involved is very, very important. And when we are discussing about the classifications involving the superalloys, when we are discussing about the nickel-based superalloys, these alloys are predominant in the range of 750 to 900 degrees centigrade due to the presence of very stable order to phase cubic centered gifted and nickel aluminum titanium provide high temperature strength. And here the gamma phase in cobalt based superalloy dissolves at 815 degrees centigrade to 1000 degrees centigrade. That shows a nickel base. When coming to cobalt based superalloys, cobalt based superalloys is called as exhibit the superior high or hot corrosion and characteristics at temperatures 92 degrees centigrade to 90 degrees. Temperature takes a major role in the superalloys for manufacturing any products. You can understand the concept of the superalloys and linking to other elements and how it will be and what are the different applications available and how it will be helpful for the society. And coming to operating temperatures of the turbine and combustion section, having the cobalt based alloys sometimes used in a lower range of 70 degrees centigrade, and how this will be reference given to the nickel based. In this cobalt based superalloys having the air or organ cap less expensive than the vacuum processed in nickel alloys. And when we are discussing about nickel based or cobalt based, the strengthening mechanism takes a major role. Strengthening mechanism having the nickel based superalloys having solid chemical strengthening molybdenum and these molybdenum are often having this addition of the elements, example like cobalt, which decrease solubility of others to promote the intermediate of the intermeta elements like aluminum and titanium to form the outer phase cubic metallic substrates, and how the gamma phase having carbides on grain boundaries, thin boundaries, top shear, and with control grain boundaries sliding. And coming to nickel based superalloys having the small additions of boron and zirconium which segregate the grain boundaries and retard the sliding process, and grain boundaries having diffusional process. Large grains, columnar grains, use system to stop grain boundary shear. And niobium having the other phases, they are not strengthening and their morphology is to control the flow. And what are the different uses of the superalloys? Superalloys having the largest applications that are like aircraft industrial gas turbines. There are different gas turbines manufactured BHEL or different industries. Then nuclear gas turbine and nuclear combustion chambers, combustion bores. This will be helpful to generate the power in different heavy turbines. Will be useful manufacturing the material is the superalloys. It also used in the space vehicles, rocket engines, submarines, and nuclear reactors. These are the multiple applications used in the superalloy. And coming to the major phases present having the gamma phase, continuous matrix of phase cubic centered arsenide, and gamma phase having the major phase. And in these major phases, content having the carbides like various types, mainly different consistence elements. And these are the concept and how the stresses will be vary, and what are the different when we are hitting the superalloys and different modules will be applied, and what are the different concepts involved in the release. And here there are the different area to how the crop condition or cash condition. You can observe the microstructure. It will observe in different research and development like nickel, aluminum, and how the structure taken place. These microstructures will be 300 nanometers. How the structures will be The structures, the microstructure takes a major role to improve the strength of these superalloys. And it will be trends in microstructure design and how they improved and what are the different appearance involved like solution into the chromium, molybdenum, cobalt, titanium, or and these are the different phases and degree of the order increases with respect to temperature. And these are the carbides, carbon percentage content generally 0.0 with having the optimum distribution of carbons. These carbides having grain boundaries and sliding into them. And discontinuous chain of the carbides along grain boundaries of the. This is the temperature capability of the superalloys. How this will be helpful for the temperature ability to maximum conditions. You can observe the maximum, yes, and maximum temperature. Minimum temperature is 760, maximum is 440 degrees centigrade. Approximately, it depends upon the different years, how the temperature capability of the superalloys. These are the forging microstructure used for different temperatures and how different lubricants used for cooling purpose. And these are the outcomes involved in this metal different environments with respect